In section 8.2, we learned about series, which is adding up infinitely many things. Just like when you've gone through math, you start with finitely many numbers that you add, and then you learn how to work with variables. We're going to do the same in chapter 8. We start with adding up infinitely many numbers, like these geometric series you've worked with so far, and then we learn to work with if we have a series that has a variable in it. So we're going to do that a lot in section 5. It's called power series. We want to deal with these infinite functions with infinitely many terms. So let's start with it here in section 8.2. The only kind we can really work with is a geometric series, and I've written 3 different geometric series here. So for A and B and C, we want to find for what values of x do the series converge. You can imagine if I plug in a 3, so I'd have 2 times 3 to the end, it might diverge, it might converge, and we would have to use the geometric series test. So we remind ourselves about the geometric series that the sum from n equals 0 to infinity, a r to the n, converges if the absolute value r is less than 1, diverges if the absolute value of r is greater than or equal to 1. And it converges to a over 1 minus r. And if it diverges, it doesn't diverge to anything, it just diverges. So when we're looking at this, for part A, we're asked about 2x to the n. So if you notice in the language of the geometric series, it's a r to the n. So the r is just anything that's being raised to the n, and the a is all the terms that are not, the coefficient. So when we're looking at A, we're looking at 2 times x to the n, so converges. We're asked, when does it converge? And I'm saying that it converges if the absolute value of our ratio, and our ratio here is x, is less than 1. Well, that has a few different ways to state it. That alone is enough, but we'd like to see it more clearly. That can be written using algebra as -1 is less than x is less than +1. You probably learned that and might have forgotten it. You just take the larger term, make it negative on the left and positive on the right, and take your inside and put it in between them. So for any x that's between those two. We often write this with interval notation from -1 to 1. They're all ways to describe the set that's centered at 0, goes left to -1, and right to +1, and includes everything in between, but it has curves, so we're not including the endpoints. All ways to describe the same thing. And so that's where it converges. It converges to a is a 2, over 1 minus our ratio is an x. So this is the same as adding up 2x to the n from n equals 0 to infinity. So if we wanted to try an example, two facts we can get out of this are that the sum from n equals 0 to infinity of 2 times 1/2 to the n, I can plug in for my x. So this is where I'm letting x equal 1/2. I don't have to try to add it out and figure it up. I know from my formula that that's 2 over 1 minus 1/2. 1 minus 1/2 is 1/2. 2 divided by 1/2 is maybe 4. 2 divided by 1/2 is 4. So we can do that. But it also says that we diverge if r is bigger. So this is an important part of the answer, because if I was to say what is the sum from n equals 0 to infinity of 2 times 3 to the n, well, 3 is bigger than 1. 3 is not inside our interval that we've said works, so it diverges, and we're immediately done. That's dangerous because I could put 3 in this formula, but it just wouldn't equal the series. So we're going to deal with that a lot later. But for now, we're just going to really care about this interval where things converge. So let's do the next 2 as practice. B, it will converge if the ratio, and our ratio in B is 2x, so the absolute value of 2x is less than 1. Well, there's a lot of ways to solve that. I'm about to mention a more geometric way, but algebraically you would just say -1 is less than 2x is less than 1. This is the algebra way. So that means that if I divide all 3 of these terms by 2, I'll get -1/2 is less than x is less than 1/2. So we're talking about the interval -1/2 to 1/2. To remind ourselves of the language, this is interval notation, and this is inequality notation, and it should be clear why. So we're going to look at the last one, C. We could say what B converges to, but I'll stop that for time. We'll just do C. So C converges if the ratio x plus 3 over 5, because those are the parts being raised to the n, is less than 1. Now, we can do that using algebra to see that that's when negative 1 is less than x plus 3 over 5, which is less than 1. We multiply all three terms by 5. Negative 5 is less than x plus 3, which is less than 5. And we subtract 3. Negative 8 is less than x is less than 2. So we've got this interval, negative 8 to 2. Another way to see this, you're used to solving equalities. If x plus 3 was the root of a function, then x would equal negative 3. So that's actually what we call the center of this solution. So the center is negative 3, and our radius is 5. So if I take this line right here, multiply both sides by the 5 because it's a positive number, x plus 3 is less than 5, then this geometrically is all x's within 5 of negative 3. So center negative 3, go right 5 to the 2, go left 5 to the negative 8. And we get the same thing. So there's a geometric interpretation and an algebraic interpretation. To finish it off, we should say, but notice they gave us the same answer. To finish it off, we should say that the sum from n equals 0 to infinity of x plus 3 over 5 raised to the n, we can use our formula. There is no a, so there's kind of a hidden 1, is 1 over 1 minus that fraction, x plus 3 over 5. So if we're good students and professors, we take the time to simplify that. We'll get 1 over 5 over 5 minus x over 3 minus x plus 3 over 5, which gives us 1 over the 5 minus the x plus 3 is 5 minus x minus 3, because you distribute the negative, over 5. The 5 and the 3 cancel to a 2, and the 5 flips up to the top, 5 over 2 minus x. So this is what it will equal, only for x's in this interval. If you plug in something bigger than 2, it won't work. Plug in something smaller than negative 8, it won't work. But plug in 4, and I could do this entire series immediately using this formula. I hope that clears up the variable question from your homework on Part D.